This is the second tutorial in a series on population. This model is what we ended up with in the first tutorial. So we have births, population, and the birth fraction. And as you remember from looking at other video, this is increasing at an increasing rate. However, this isn't complete because, as we know, populations decrease over time based on deaths. So we're going to click on the rate button here, and we're going to create a flow going out of the population. We're going to call it deaths. So we have births and deaths. We're going to create something like the birth fraction, but we're going to call it lifespan. So that would be the average lifespan of the people in the population. So next we're going to connect the information arrow like we did in the births, and connect the population also to deaths. So we grab that little circle there and separate these so it looks a little clearer. There we go. So now the part on the right looks like a model that we had before. Should be decreasing at a decreasing rate, and on the left we have births that represent increasing at an increasing rate. So we might wonder, what is this graph going to look like when we get done? First, let's go to the model settings and make sure that we've got the right model settings. So we're going to look at it for the time over 50 years. We're going to use a time step of 0.0625. Units for time are year, and the integration type is going to be RK4, Runge-Kutta 4. Okay, model settings are in place. We need to check our equations, so we're going to push the button for equations, and these things pop up here. So we're going to look at the population is births minus deaths, and the initial value is going to be 100,000. The equation for deaths is going to be the population divided by the lifespan. So what does that mean? Well, that might be something you want to ask yourself and see if you can answer yourself. The population divided by the lifespan would be the people who live for the average number of years. How many people live for the average? And what are we going to use for the average? We're going to use 76 years for this model run and see how that number works. Okay, so we've checked all of our equations. We've entered our initial values. We've got our model settings already checked, and we're going to run the simulation. And Vensim wants me to verify that I'm going to get rid of the old data. Yes. And now I'm going to look at the graph. We want to look at the graph for population. Click on that. The graph for population. Wow. Looks like a straight line. So increasing in a linear fashion. over 50 years. Looks like almost 10,000, almost an increase of almost 10,000 in the population, so almost a 10% increase. So what does that mean in terms of births and deaths? Let's see, so is the number of births greater than the number of deaths, or is the number of births less than the number of deaths? What would cause the population to go up? Fewer deaths and more births might cause the population to go up. And that's what we see here in this graph, is that there are more births than there are deaths over time, and so the population increases. And that finishes our second tutorial on population.